Okay, now let's us discuss about the implementation of analog input by having this example, which is simple analog input example for the purpose of uh, showing you how to use an analog to use the port analog input inside the Arduino. Then we will use the potentiometer. Okay, just remember that if you want to use the analog to use Arduino, especially for the purpose of using the analog input, then you need to use the special port here, which is A0 until A5. Okay, if you I just recap back what we have learned before, which is this one. Okay, in order for you to use the analog input, okay, if you want to use the analog input inside the Arduino, then you need to use the one that labeled as yellow as this one, because A0, again, I would like to remind you, A0 until A5 is a special port for analog input. Okay, so you cannot use this port for other things else. It's not similar with the green one. Okay, the green one, it can become input, digital input, it can be digital output, it can also become analog output, which is the one that labeled with digital PWM. That is the one can be used as digital output. Okay, now we talk about analog input, where you need to utilize either one of it, either one of A0 to A5. Okay, the main purpose is of course to reading the analog value. It's not similar to digital input like we have discussed previously. Okay, as you can see, like the one that we have discussed, which is using um, the switch there, or the press button there. Okay, it only provide either 5 volt or 0 volt to this port 2, so which is why this port 2 become digital input. It can only read either 0 or 1, or 0 or 5 volt. Okay, but for analog input, the one that we have here, okay, A0 until A5, it have capability to read the range of the range of voltage from 0 to 5 volt, meaning it's not just 0 or 5 volt. It can read 0, it can read 0.1, it can read 0.2. So the range there, you can up into 5 volt from 0 volt. So that is the specialty about the analog input in port A0 to A5. Okay, it can accept that range of value. And then the function that you need to familiar in order for you to operate this analog input is, again, you need to familiar with the pin mode. Of course, the pin mode we need to set as that port to become the input port or input pin. And then you also need to use the function called analog read, where this function is almost similar with digital read, but the digital read that we discussed in this previous example is to read the digital signal only. That's why it can only accept either 0 or 1, that represent 0 or 5 volt from this that is sending from this wire to this port number 2. But for this function analog read, okay, it's only applicable for if you are using this analog port, which is A0 until A5, where actually any signal from here, okay, it can be 0 volt, it can be some value where it can be up into 5 volt, and that value will be changed into digital value that represent that voltage. For example, as you can see over here, in general, but in the programming itself, if you applying the analog read, any value which is go into here, if the value is 0 volt, the output of this function is 0. But if the value of this line is 5 volt, then the result of this function, it will return 1024, okay, which is a 10-bit analog to digital converter inside this analog port. Okay, there is some advantage. I just give you some explanation in detail. Actually, inside this analog port, actually there is 10-bit a 10-bit analog to digital converter, meaning that if you have 0 voltage going into this side, it will convert into 0 value, and if you have 5 volt going into port 0 here, it will convert by programming. It will convert, if you execute analog function, it will return 1024, which is a 10-bit to the power of 10 minus 1. So of course, if you, let's say, the signal come from this line into this port A0 here is 2.5 volt, then you will get, if you apply the analog read function, it will return, of course, it will return 1023 divided by 2 lah. So it's 500 something, the value, okay, 500 something. So that is how actually, again, like we have discussed before, even the signal, or let you assume just this, the signal from the potentiometer is come from the environment, or come from come from some sensor. Okay, it will give you some value. Okay, that value does not only 0 or 5 volt, it can be some value which is in the range of from 0 to 5 volt. And then if that value is signed or is read by this analog port, it will automatically convert into some integer value from 0 to 1023 value. Okay, from 0 to 1023 or 1023, and this is the value that have been stored in your any variables that you set in your programming. So again, why is that happen is because your CPU is only allowed to process the digital signal, the integers or the discrete value. The continuous value cannot be accepted, which is why in your programming, the 0 to 5 volt, the range of analog signal from 0 to 5 volt have been converted into the value of 0 to 1023, whereby 1023 is represent the 5 volt in analog electrical signals. Okay, so this circuit in just showing you example. That's why we are putting a potentiometer here. So this potentiometer, of course, is not, again, the potentiometer is not generating the electrical signal. The electrical signal is come from this 2 point. This is 5 volt, and this is ground. So by the time you vary this resistance, but the voltage reading here is keep changing. So if you change the value, the voltage is also changed in this line over here. Okay, because you are tuning the potentiometer here. So this one can be the range can be from 5 volt to 0 volt. Okay, just imagine your your radio. Okay, the volume of your radio, or in general it can be also your car radio. Okay, your car radio, the radio in your car. When you want to tune the volume, you assume the volume itself is a voltage. So that voltage can be changed by changing the volume. So it same goes to this potentiometer. If you change if you turn the potentiometer, it will vary the resistance. Once the resistance is vary, it will give different value, different voltage signal in which is come from here to this wire. So that's why this analog A0 will keep reading different electrical signal, electrical voltage value, whereby it's depend on what are the position that you turn in potentiometer. So but the range is from 0 to 5 volt. Okay, but again, uh, just we vary this potentiometer just to want to show that if we change the analog signal, we still can read the signal, but in programming, the signal which is in analog, whereby the range is from 0 to 5 volt, will be changed into 0 to 1023. Okay, so in Tinkercad, this can be represented by this. Okay, the same potentiometer. Okay, just yeah, the same. The one, this potentiometer is inside here. This is the potentiometer, and this is the 5 volt support. This one, this ground is the another lead, which is this one, and then the one that connected with analog A0 here is this one. Okay, so how we want to see how we want to show that whether the analog input operation is working or not. So again, pin mode, the obvious function, you need to set your A0 because you're using A0 as the input. Of course, this one we just do some simulation with pin number 13, which is why we also set the pin mode for pin number 13 as output. And then okay, this one is, of course, you see the first time you see this one is when I showing you some hello world example, when we want to use a printf, where that printf things, which is equivalent to serial.println here, will be display any things when you execute this one. It will display to the serial monitor, which is the Arduino borrow your screen, your computer screen, to become the monitor display for Arduino. So the same thing, because we want to see the reading of this analog value, that's why we need to print something here. Okay, once if any changing over here, it will keep printing the value. So you can see that why we set on this one, because for the purpose of utilizing the serial monitor. Okay, but the main things I want to discuss is this one. Okay, we already set our A0 with as an input, and then of course if you are using the analog input A0 here, port A0 here, then this is the function analog read, is for the purpose of reading that analog value. So anything comes through this value from 0 to 5 volt, it will return and store in this variable, where again I said the value will be any value in the range from 0 to 1023. 1023 is represent 5 volt, 0 represent 0 volt. And then this serial port here will printf, it's like a printf, it will print this value in your serial monitor later. And then okay, let ignore this instruction first. Okay, just you have two line over here. Okay, again let's ignore this one. Later I will try to comment this one, so it will not execute at all. This 4 line, we want to see if you are changing if you are assume there's no instruction for this one. Okay, let's assume this one have been deleted in your program, so you only have these 2 line for. So what's meanings there, when there's a loopings there, it will check the analog value, analog read in this port. It will store or return the function, return the value of this analog read. It can be from 0 to 1023. So every time it's returned, it will print into your serial monitor the value that given by this sensor value, and it will keep repeating the same things. So we will see what happens there. So let's prove through the Tinkercad. Okay, this is the same code there. Again, I just comment this one, so we just ignore this part first. Okay, we ignore this part. Okay, everything's, we just read the analog value, means that any value from here will be go into this one, the analog signal, but AO, after you apply the analog read, it will convert this analog value into digital value. That's why you only have from 0 to 1023. 1023 represent 5 volt, 0 will represent by 0 volt, and then we'll do some printf there through our serial monitor. If we execute this instruction, or if we execute this code, so you can just open your serial monitor, you can see that now the value is 491. Okay, I don't know 491 represent what value in as an analog electrical signal, but if I tune this potentiometer, okay, fully in that things, now it becomes 0, so meaning that now it's a 0 volt. If I want it become 5 volt, okay, I just turn this one, okay, as a full value there. So that's why you get 1023. In other words, 1023 is 5 volt, and then if the value is 0, actually that is 0 volt in this signal. Okay, the signal that that accepted by this A0 port is 0 volt. Okay, maybe we can try to put some multimeter to check whether it's correct or not. Stop simulation, then multimeter. Okay, start simulation. Okay, it's 0 volt, right? So if I tune this potentiometer, let's say I tune it into 2.5 volt, now it become 5.1, which is half from 10 to 3. So you can see there, okay, that is the proof. Even the analog signal is going into this A0, the value is 2.7 volt, but in programming 3.7 volt actually is represented by 257, so it can go up into a range of 5 volt, where the 5 volt is 1023. So I hope by that example you might have some familiar on how to implement the analog input for your project. Okay, so that's one thing. Now the other things that you can make, that is the one that we already comment there. Let's uncomment that. Okay, we have turned on the LED number 3, and then we delay. So we delay, you can see we delay our LED to be turned on. Okay, after we turn on the LED, we delay with the sensor value which come from here, meaning that this sensor value you can have from 0 to 1023, meaning that now that value will become the timer for this LED blinking. So if you have increased the potentiometer up into 1023, it will have a slow blinking there. But if you make it 0, then the blinking will become more and more faster. Okay, that's why we just integrate between this example and the LED blinking example, so it's more interactive there, and then you can have an idea on how to integrate between the analog input with digital output, where the digital output is the LED, the analog input is the one that adjusts by the potentiometer. So if I run this code, okay, if I run this simulation, okay, so that is full 1023 delay there. The delay is 1023 microsecond, or is equivalent to 1.023 second delay. So if I reduce the potentiometer, okay, I reduce the potentiometer, now the blinking is keep faster. Okay, so this one is a little bit slow, and then I reduce a little bit faster the blinking there. Just see this one. Okay, so if I put 0 there, then you cannot see at all because it's turn off and turn on and turn off very quick, so that's why you cannot see. So that's why you need to put a little bit values there, so then you can see the, okay, even this one you cannot see the blinking. There's a very fast switch there between turn off and turn on. So the highest the value of voltage, then it will represent the delay in LED blinking. That's why once you increase the voltage, the delay of between turn on and turn off is keep expanding there. It keep more and more longer than before. Okay, so that's all about the example how to use the analog input in Arduino.